Okay, so for my natural selection lab, I have, I don't have a name for it, but basically I break up my class into 3 different groups, and they have 3 different ways of feeding. The first way that they feed is with their fingers. I call them pinchers. The second one I call them knucklers, and the third I call them stumpies. And their food is basically cork, or you could use anything of similar size. And so the pinchers just pick it up, the knucklers kind of have to get around it, and the stumpies have to actually use both to pick it up. And so I take my students outside, spread it out over the grass, I have them circle up, and 3, 2, 1, go. They got to get food as much as possible until it's gone using their exact feeding method. And when they're all done, I have them go back and I tell them how many they needed to have to survive. And so say it's 4 they needed to survive. If they have less than 4, they're dead. So I collect them all, and the dead now go off to the side. And what are left are the people who are ready to now mate. And so I tell them to find a mate that they think will ensure their success, their offspring's success. So everybody wants to mate with a pincher because pinchers have it easy. So they pair up, and basically then in order for them to reproduce, I kind of build off a lab that I do before, which I call coin sex lab. So they have coins that are labeled to represent each of the sex, or each of the copies of the genes that they have. And so the pinchers are a little a, they're homozygous recessive. The knucklers are big A, little a, and the stumpies are big A. And so say it's a knuckler, they're going to pull out the coin that has a big A on one side and a little a on the other side. So say 2 knucklers come together, they're going to pull out their big A, little a coins. They're both going to flip, which simulates meiosis. They pair them together, it simulates sex, and they find out what they have. So say they have a little a, they actually have a pincher. Then I come around and I find out what each pair had, and the dead people are now kind of respawned back as the offspring. So now they have a pincher. And so at this point, I have the class split up into their 3 groups. I have the students calculate, all right, how many stumpies do we have, how many knucklers, how many pinchers, and that's our new population. And so we repeat that whole process over and over and over again, and there's a lot of interesting things that kind of start to happen. As you would expect, the stumpies really struggle, and so we see this really quick shift towards the pinchers and knucklers, but there's some odd things that happen sometimes, and one of the things I love to watch is when the stumpies get wise to the fact that they're on the outs and they start to work together, and when they're working together they actually can be a bit more successful. They can kind of crowd out the pinchers, and so then you start to see this split in the population. You actually start to get kind of a speciation event where you get stumpies and pinchers, and actually I've seen no knucklers at all at one point. And then you know, you get the occasional knuckler that'll come back in. And so you see a lot of interesting patterns that come along. And then there's also conversations about sexual selection. And also another thing that I love that happens all the time is students cheat. And it brings up this whole idea of, like, why do we cheat? And what's the reasoning behind that? And in this activity, it's a struggle for existence. They're fighting to survive. So a lot of great talking points. It's a lot of fun to watch. And kids actually really grasp natural selection at that point, and we then go back into the lab and we do the number crunching. And I've only ever done this with biology students, but now I'm going to start scaling it up for my AP Bio, and we'll really do Hardy-Weinberg. Before we really just looked at, I just said allele frequencies, which alleles are becoming more common, but you can, I think, really take this up a couple notches. Yeah. So it's a lot of fun.
Great. Thanks.